Welcome everyone. In this lab, we are going to continue with the spatial analysis and geocomputation on all countries. We will make a population density map of the world. So first we import GeoPandas as GPT and we load countries underscore all shapefile as countries. So this is how we do that. So countries equal gpd dot read underscore file of the name of the shapefile here. So it has to have dot shp. Now you can access the data as a geo data frame object. So display the countries. So we have source column, country name, square kilometers, population 2007, population 2015, total CO2 underscore 200, GDP underscore US dollars, and the geometric column. So in the geometric column, you can see multi-polygon, more than one polygon, and there are single polygons as well. And printing the country info, we get countries.info open and close bracket. So this will give some information on the columns. So there are 247 observations and there are 8 columns, and 2 of those source and country name are of object type, and the rest so there is a geometric column and the rest is float 64 columns. This dataset contains 247 observations of 8 fields of source, country name, of source, country name, square kilometers, population 2007, population 2015, total CO2 underscore 200, GDP underscore US dollars, and geometry. So we'll put geometry here. Okay. So next, some of the rows in the data set have not applicable values. In order to delete them, make a subset of countries with rows where population 2015, these are capital letters, is higher than 0, or eliminate rows with not applicable values. So we want population 2015 to be higher than 0. So this is how we do that. So countries 2 equal countries, and we will subset the population 2015 with more than 0. And when we print that, you can see that we have 224 rows. There are 224 rows with population 2015 more than 0. We subset the invalid data observations and saved the valid observations in file name countries2. We will further work with countries2 dataset. Next, we create a variable population density 2015 in the countries or countries2 datasets by adding a new variable pop underscore dense. Population density equals the total number of people divided by squared area. So that's pop 2015 divided by SQKM. Reset the index of the data frame, so we can see that the index does not start with 0. It's 1, 2, 5, 6, 7, and so on. So let's put that into ascending order. So this is how we do that. Countries2 equal countries2 dot reset underscore index, and we want to drop the old index. So drop equal true, and on printing the first few lines we get the new index 0, 1, 2, 3, 4, and so on. Then we calculate population density. So we create a new column pop underscore dense equal. Now what we will do is that we will divide the population 2015 column by the SQKM, the square kilometers column, and we'll round that to 0 decimal place, and on printing the head we get a population density column created over here. So you can see population density for country name French Guiana is 3, and for Guyana is 4, St. Helena is 87, Suriname is 4, Trinidad and Tobago is 223. Then we will do some plotting, and to do that we will import Seaborn as SNS, and we will import matplotlib.pyplot as plt. Now there will be warning signs because we are plotting the density plot over here, so we want to filter those warnings. So this is how we do that: import warnings, and to suppress all warnings we pass this command warnings dot simple filter open bracket ignore and close the bracket. So we make a population density map of the world. So sns.kde plot open bracket data equal countries 2 comma x equal pop underscore dense comma color equal blue close the bracket, and we add a title to the plot using the x object after creating the plot. So x equal plt.gca open and close bracket x dot set underscore title of the title population density distribution, and when we display the plot we get this. So we can see that there is a peak, very high peak around 0, and the rest is there is no peak, it's just skewed. So we provide descriptive statistics. So countries 2 of column population density, and when we describe that, we can see that the minimum is 0. The population density in the year 2015 is distributed from 0 to maximum 1,812,932. More countries are having density less than the median. Should be median. Median of 90. So more countries are having density less than the median of 90. Okay. XY is it's around 0. There is a high peak. Then we will do some GeoPandas mapping, and to do that we will do import folium, and if we print countries to data set, we see that we have population dense column over here, so population 2015 and the country name, so and then the geometry, so we meet those columns. Then we will import random because we will use the function to generate random color. So definition random underscore hex underscore color open and close bracket in the columns color equal, so this hash sign plus, and then the empty space dot join, and then in bracket we will have hdr bracket hex bracket random dot rand int bracket 02255, and we close the bracket and square bracket 2 colon 4 underscore in range 3 and dot upper open and close bracket retain color. So assuming GeoJSON is a GeoJSON string or file representing world borders, so we'll have world map equal folium dot map open bracket location equal 0 comma 0, so latitude and longitude is 0 and 0, and the zoom is underscore start equal to adjust initial location and zoom. Then we assume countries 2 has a geometry, so we don't have to assume this. Countries 2 has a geometric column with GeoJSON data for each country. For rows in countries 2 dot iterate tuples open and close bracket and then the colon folium dot geojson open bracket data equal rows dot geometry comma fill underscore color equal random underscore hex underscore color open and close bracket. So it calls this function over here to generate the color and close the bracket, and we add that to add underscore to open bracket world underscore map and close the bracket. Create a marker from GeoJSON feature. Marker equal so folium dot marker and open bracket location equal so square bracket rows dot geometry dot centroid dot y. Remember we have multi polygons and polygons, that's why we are having centroid comma, so we will put the marker in the center of each of the geometry. Rows dot geometry dot centroid dot x, close the square bracket, pop-up will show the country name. So marker we will dot add underscore to the world map, and when we print the world map it prints this. So when we click on the marker we see the name of the country and then the value. So that value is so country name and colon. We also have population dense, so the density of the population, and CEX equals 0.4, so that's the size of that label. So yeah, so country name and then the population dense. So Mexico has population density of 61. And what is this country in the ocean? St. Helena has population density of 87. And this country, Congo, DRC, it has population density of 35. And what else we have? Let's do some more. So this country, Russia, population density of 1. Oh, okay. And Mongolia, population density of 2. Japan, population density of 339. So Japan has more population, very high population compared to amount of land present. And India has 404 population density, very high. compared to the amount of land area, the square kilometers um, present. And this one, Kazakhstan is 6, um, 42 for Iran. So that's the population density. So 42 people in every square kilometer. In Jordan, 82. Libya, 4 people in every square kilometer. That's good. Algeria, 16 people. And let's look at this island, this inside the ocean. Iceland, 3 people in every square kilometer. And what is that? Greenland. Greenland is 0 people per square kilometer. And yeah, so by clicking, in Canada is 4 people per square kilometer. Okay. Next, we extract the row with maximum population density. So countries 2, so we subset countries 2, the population density equal maximum of the population density, and we get Maldives. Maldives, the population density is 1,812,932. Okay. Very high. Extract the row with minimum population density. So countries 2. So we subset the population density with minimum population density, and that's Greenland. Greenland is 0. So yeah, it's a rounded figure. So we can see that population in 2015 is 56,321, and the square kilometers of land present is uh, about 2.1 million. And one of the things, maybe Greenland is a very cold country to live. Greenland has the lowest population density of around 0, and Maldives has the highest population density of around 1.8 million. In 2015, Maldives was highly overpopulated. Okay, group your population density into 7 classes. So to do that, we import pandas as PD, and we use cut function for classification. So that is from the pandas library. So breaks equal pd.cut, and then inside the bracket we will have the pop underscore dense colon, and we want to cut that into 7 slices, 7 intervals, and when we print that we get this, and the 7 intervals are when we print the 7 intervals, so it's minus 1812.932 to 258,990.286, less than this interval, less than this interval, less than this interval, less than this. So there are 7 intervals created. Create a new column with class labels. So the countries to population underscore density underscore class equal breaks. So the breaks that we created, and countries to population underscore, when we print the head of it, it prints the first 5 rows for that population underscore density underscore class. Get this. Then we print the class intervals. So we print breaks dot value counts. So we can see that population density is mostly in the range minus 1812.932 to 258,990.286, and there is one in the range of about 1.5 million to 1.8 million, and the rest is zero. Majority of the countries have population density in the range minus 1812.932 to 258,990.286. Then we identify the scheme of colors. So import NumPy has NP, and we plot a choropleth map of population density with a legend and a title. So let's have a look. We don't want this, so we will remove this cell. Okay, we import map classify. Okay, we will need map classify. Do we need it? Let's have a look. We'll find out. So create a color map for population density. Colors equal plt.cm.viridis. Define quantiles for coloring instead of bins. So Q equal the population density dot quantile. And inside the bracket, we will have square brackets of 0, 0.25, 0.5, 0.75, and 1. Adjust number of quantiles if needed. Create the choropleth map. So fig, x equal plt dot subplots, bracket, fig size equal bracket, so 10, 6. So height is 6 and the width is 10. Adjust figure size for better readability. So countries 2 dot plot and bracket, column equal pop underscore dense, and x equal x, comma cmap equal colors, which is plt.cm.viridis, scheme equal quantiles. So quantiles, this is the scheme, comma k equal length of q minus 1. So length of q minus 1 is k, and legend equal true. Use the scheme equal quantiles. Then we add a title and labels. So PLT title, bracket, population density, people per square kilometers by country 2015, and plt.x label longitude, plt.y label latitude. Show the map. So we have majority of the population with population density, majority of the countries with population density from 0 to 34, and there is few over here. India is having population density from 309 to 1,812,932, and there is green one which is 90 to 309.75. The green one, this is China, and this is India, and we can see majority of the countries are with low density, and this teal color is for 34 to 90. Okay, majority of countries have population density in the range 0 to 34. Then we save our map as a JPG file. So save the map as a JPG file, which will replace map.jpg with your desired file name. So fig.savefig, bracket, comma. So we will put the file name over here. We will keep it as map.png. jpg, comma, dpi, this is the size of the file, the amount of pixels, and that's 300, bbox underscore inches equal type. So then we adjust dpi for quality. So code used to create the map, copy and paste this into your report. So when we run this, this will save this file in the directory that we are using.